All right, this is an example that asks us to compare some atoms and molecules that are nonpolar and try to decide why the boiling point data goes in the direction it does. So if you look at this, our boiling point is increasing as we go down a group from one period to the next. So going down the group, what we know is that we're getting a new electron energy layer. And it tells us if we look at this data, we know that going down a group, the boiling point increases. The boiling point keeps increasing as we go down a group. Why is that? Well, the first thing that we know is going down a group, the energy level, the number of energy levels increases. What that means is as you're going down a group, you get a larger electron cloud. So your electron cloud size increases. Larger electron cloud. It's bigger, it's easier to distort, so that means that it is more polarizable. It's more polarizable, or it has a higher polarizability. So what that means is the strength of LDF increases. Now keep in mind, comparing the strength of your LDF to determine the boiling point, this is really only going to be effective if you only have LDF. So if you have dipole forces going on, you have to also consider that. But if we're just comparing nonpolar molecules, which is what we're doing in this case, the strength of the LDF being greater tells us that the boiling point is going to increase. So the strength of LDF goes up and the boiling point will also go up. It's harder to break those bonds. We have stronger intermolecular forces. We have a really important note down here. Note that the polarizability of a molecule and dispersion forces generally increases with the size of the atom or molecule. But when you compare two substances on the basis of their London dispersion forces, you should always talk about the size of the electron cloud and the polarizability. This is the key. Do not explain it like this. X has a higher boiling point than Y because it has a greater mass. That is incorrect. So don't do that. Don't do that. I'm going to erase that X so we make sure we're not going to cross it out because I want you to be able to read it. But yeah, don't do this. This is the wrong answer. Okay. It has nothing to do with mass. It has to do with the size of the electron cloud or the number of electrons. Even though the trend is very similar, if you answer the question this way, you will get it wrong because it is not the reason. The reason is the number of electrons. So put a star by this, and don't forget, if you're comparing LDF, you always talk about the size of the electron cloud, not the mass of the atom.